so let's work on it right now. So as we just looked at a problem similar to this one, but a little bit nicer with the square root and whatever it was, x to the third or something, or 3x. So here, first step, we have to replace this by y. Then we apply natural log. So it's sine of natural log of secant x. Then we differentiate both sides. And this is 1 over y dy over dx. And this is cosine and natural log of secant x. And then plus sine. I always run out of room with these markers, so I'm copying it here. And 1 over secant x times secant prime, which is secant x tangent x. I'll simplify a secant. So then I have dy over dx equals y, which is secant x raised to sine x, and then cosine x natural log secant x, and plus sine tangent, sine x, tangent x. Oops. The other one, number 2, s prime of x equals 8x, negative 8x plus 32. So I think we were asked to find s prime. This is velocity also. So we were asked to find the velocity at 1 second, I think. V of 1, I think, right? 24 feet per second. And then, yes. And then we were asked to, first of all, we have to find V of t equals 0, which I browsed through, so you determine that x equals 4. And then I was hoping that you, in your notes, you're going to write this. Not in the solutions, of course. I wasn't asking you to do that. But I'm hoping that you wrote this, 0 to infinity, and 4, and 0. And the slope here, when you plug in a number between 0 and 4, you get a positive number to the right-hand side. So this is the positive direction, and this is the negative direction. And I saw that in many of your submissions. You said positive between 0 and 4 and negative after. Awesome. It was very good. Okay, so let's continue and try to finish this. I'm sharing my screen again. Here, I would like us to choose a problem from 31 through 36. And you can say, who cares about this? I have a calculator. So what are you trying to say? Okay, allow me to choose 33. Or if you want to choose, I'll wait. It doesn't matter. You want to choose, or I'll choose 33?
I think 33 is fine.
Okay, thank you. So this is the cube root of 1001. Okay, so we're asked to use the formula for approximation. And please remember the formula is x plus dx. F of x plus dx is approximately f of x minus, plus f prime of x dx. What does this mean? And how do I use this to the cube root of 1001? You can say, who cares? I can plug in 1001, put the power in parentheses 1/3, and I get an approximation. So with the calculator, I get approximately 10.0033332222. But I don't want to do that. I want a quick approximation. I don't want to determine this. I determine it so we can compare. But we don't need that. We just want to approximate this quickly. And how do I do this? Well, I have to identify the function is number 1, x is number 2, and 3 is dx. Once I determine all these, I can fill in the rest. But I have to identify for this, the function, x and dx. What do you think is the function that we are looking at? When I look at this, what function am I really looking at?
Cube root of x.
Of course. which I know is the same with x to 1/3, and I have to determine because I need f prime, I will have 1 over 3, because it's x to 1/3, x to negative 2/3. Okay, so I identify number 1. I also have its derivative. I need to identify number 2. What do you think when you look at this? Can you identify, remember, there was a very good question a minute ago, or 10 or 15 or something like that. What does that d theta mean? D theta has to be very small by comparison to x. So when you look here, what would you say? What is x, and also what is dx? Because that will be my next question. And you will identify x based on the function that you see here also, right? And that's how you identify dx also. So what is
1001.
Careful. If x is 1001, then what is dx? Dx cannot be 0. So what do you think x is here, and what is the error in x?
Oh, 1001.
Of course, of course. And because the cube root of 1000 would be
10.
Exactly. Something very simple, right? Because if I need to use calculators on this, then what's the point? Then I can find it and use the approximation. Awesome. So stay with me. All this piece now is the cube root of 1001, and this is approximately. Again, what is f of x? How much is f of x?
10.
Yes. Plus 1/3. And x is 1000, you already told me, to negative 2/3. And this will give us the answer. It will be an approximation of that in a fraction form. So I have 10 plus 1 over 3, and this will be the cube root of 1000 squared. But the cube root of 1000 is 10, and when I square it is 100. So this is 10 plus 1 over 300, or 3001 over 300. And very simple. I'm going to share my screen. Here it is. So 3001 divided by 300. Look at that. And the cube root of 1001. Look at that. And you didn't even need to know to take the cube root by hand. By simply calculating this, you get the same thing.
Can I ask you a question while you got the graphing calculator up?
Yes?
I was using the graphing calculator over the weekend, and I was wondering, is there a way to use like the variable x without giving it a number that is equal to? Or use any variable without giving it a number that is
Yeah,
equal to?
you can use this and graph it, but there is nothing else you can do.
Okay.
Yeah, you can use in y equals and graph it, or find x-intercepts, or whatever else you need. I'm not sure exactly if that's what you meant, though. I'm not sure, but yeah. I don't know if you want to put 2 times x. I don't know if it's going to do anything. I mean, maybe it has an x built in somewhere, a value, but
Yeah, you can change any of the variables.
yeah, in the store, yeah, to store a number in a variable.
Yeah. So that's why I was trying to figure out, like,
Yeah,
what happened if
I
I
don't know
would
what the purpose of that would be, but yeah, I guess, yeah. Good. Okay, back to, is it clear how this approximation and calculus, they didn't have calculators initially. So that's how they approximated the cube root of 1001. And many other calculations, like, for example, cosine 29 or e to 0.1. Who knows what e to 0.1 is, right? But we can approximate it using calculus. Okay, so can we look at a word problem now to see how this applies in word problems with the error? So what about the circumference of a sphere was measured to be 84 centimeters? I'm on page 10, so this is 43. So 84 centimeters circumference. Okay. With a possible error of 0.5 centimeters. Use differentials to estimate the maximum error in the calculated surface area. Okay, the surface area of a sphere. So we don't need to memorize the surface area. I'll explain how we get the surface area. What is the relative error? Okay. So the volume of a sphere is 4/3 pi r cubed. So this is volume sphere. It turns out that the surface area is the derivative of this. Bring 3 down, so 4 pi r squared, the surface. But you have to know something. So you have to know at least the volume of the sphere, and then by differentiating, you have the surface area. So they're telling us that the circumference, which is 2 pi r, the circumference is 84 centimeters. Now the question is, they're telling us that there is an error. In order to make sure that we understand what we are trying to do here, instead of the circumference with uppercase C, I'm going to denote this by X. You'll see in a moment why, because I want an answer from you. What will this represent then? And remember, one of them has to be big and the other one tiny.
dx.
Exactly. Yes, I know you understand that this is C, which is 84 centimeters, and this is DC, which is 0.5 centimeters. It doesn't matter to me if we continue with X or with C, but I want you to understand what this means. So the circumference should be 84 centimeters, but because it has an error of 0.5, which now is 84.5, of course that will affect the surface area. It would have no problem if I plug in 4 pi r squared, and the circumference, remember, is 2 pi r. I have to solve for r. I have to find r and plug it in, and I'm done. But there is a problem. And what is the problem? It is that the circumference has an error. They're asking us to determine the approximate error in the surface area. They're asking us to find ds. Can anyone for this function, first of all, give us ds? This is the approximate error in the circumference created by this. So we have to find it. And we know that there is a difference between, we looked at it a few minutes ago, or maybe 20 minutes, half an hour. There is a big difference between the derivative and the differential. So can anyone give us the differential of this function?
Would it be the equation for the volume? So 4/3.
No. I
Plus-
only connected so you don't have to memorize this, but from here you can determine that. There is no volume here. We have a function s of r, which is 4 pi r squared. We want to determine ds for this function. Can anyone find the differential of 4 pi r squared? Anyone would like to try? Anyone? Zoe, would you like to try? It's okay if you're wrong. Okay, Zoe is not with us. Let's say Brooke, are you with?
No, I am.
You're-
I'm not sure.
I mean, I'm sure that everyone can differentiate this function with respect to r and multiply by dr. Everyone can do that. There is absolutely not one person that cannot do that. Okay, Michelle, would you
What
like?
I'm
Yeah.
missing is how we get ds or dx from that based on what we have. So you said it now, differentiate, but I think that's where I'm still like, I don't know what the next step is.
Can anyone differentiate this function for us?
8 pi r.
Is that just
Okay, so 8 pi r dr. That's all I wanted you to say. Everyone can differentiate this function, even if we don't know anything about anything, right? 4 pi r squared prime must be 8 pi r. But because we are talking about ds, it has to have dr, because that's the function, that's the variable. Is this okay with everyone?
Yes.
Okay, now let's come back here. There was a question about this or something. Can anyone tell us what the question was? Again?